When presented with a three-term polynomial, aka a trinomial, it's very likely that it can be factored into two binomials. Last unit, what we did is we took two binomials, such as 2x plus 3 times x plus 1, and multiplied this out, and it turned into a trinomial, like 2x squared plus 5x plus 3. So when we factor trinomials, we're actually starting with the trinomial and going backwards to the binomial. And basically all we do is we use a little bit of number sense and guessing and testing to figure out which two binomials would produce this trinomial. So in this case, I know that I'm going to have two binomials, and the first two terms, when I multiply them together, are going to be 7x squared. Well, to get a 7x squared, the only two things that would produce that would be a 7x and a 1x. So I'm just going to put those there, and they're going to stay there forever. The next thing we know is that the last two terms are going to multiply together and create the 3. Now, there's a whole bunch of different ways we could get 3. And one we'll just try right off the bat is positive 3 and positive 1. So the first two terms will multiply to give us 7x squared. The last two terms will give us the 3. But what we need to check is if the middle loops, so to speak, are going to give us the negative 22x squared. That's where the checking comes into place. So for my first guess, this would give me a 3x plus a 7x. And 3x and 7x do not equal the negative 22x. So the 3 and the 1 are not correct. So we'll try something else. Now here, if we use some number sense and some logic, we can save ourselves a lot of guessing and testing by thinking about this is a negative 22x. In order for that to be negative and these two ending terms to be a positive 3, these are both going to have to be negatives. And then we can go from there. So maybe let's try 1 and 3. That looks like that's going to give us, I think it's going to give us what we want. Because there's a negative 1x and a negative 21x. So when we add those up, we get negative 22x, which was the middle term that we wanted. So in this case, the factored form would be 7x minus 1 times x minus 3. And again, we just guessed and checked, but if we use some logic, we can cut down on all the different possible combinations. All right, let's look at another one. So let's just try something. Let's put our two binomials. Let's try a 4x and a x. Another thing we may have to try is a 2x and a 2x. Those would be the two possible ways to get that 4x squared. So again, thinking that this is going to be negative and this is negative, one of these is going to be positive, one negative. Not exactly sure which one, so I'm just going to jump right in. I'm going to try just a negative 3 and a positive 3. Oop, I put 4. Let's put 3. So that's going to give me a negative 3x and a positive 12x. Okay, well that gave me a positive 9x, but I need a negative 9x. So I think if I just switch the positive and negative signs, then it should work out. So let's make this a positive 3 and this a negative 3. So now, when we check that out, that's going to give us positive 3x and a negative 12x. And that gives us our negative 9. So then these would be the two binomial factors. It'd be 4x plus 3 and x minus 3. So that one we didn't even have to try that there because it actually worked out the first time. Okay, let's try this one. You'll find that whenever you're factoring a trinomial where the leading coefficient is 1, like this, they're a little bit easier, a little bit quicker. So that's an x, and it's because these are both 1x and 1x. So two numbers that multiply to negative 80. Well, when we do our loops, they're both being multiplied by 1, so that makes the testing really simple. So basically two numbers that multiply to negative 80 that are going to add to 2 when we do our loops. So that would be like 8 and 10. And since it's a positive 2x, it should be like a positive 10 and a negative 8. Because there's our 10x, and there's our 8x. Negative. So there's our 2x. So the factored form would be x plus 10 times x minus 8. Okay, one last type I want to show you, very similar to the previous one in that it starts with just x and x. In this case, the two numbers that work are a 5 and 5, both positive. There's 5x and another 5x. So that's 10x. What I want to point out about this problem is if you ever have two binomials that are the same, so x plus 5 and x plus 5, you want to rewrite that as x plus 5 squared. And that's going to be useful for something we do later on, and it really simplifies the problem, makes it smaller, and the smaller and more simple it is, the better. So again, anytime you have two of the same binomials, write them as the binomial squared. Okay, why don't you pause and try this one? And here's the answer.